Welcome back. In this video, I am just going to wrap up the last part of Unit 2. In Unit 2, we've seen a lot of things. We started with declaring variables and some basic preliminaries. Then we wrote from simple programs to complex programs in Unit 2. We looked at different sorts of structures, like your switch statements, if statements, conditional statements. And we also looked at recursion, and now we're going to wrap it up with unified modeling language, also known as the UML. So let's go. So now I'm just going to scroll through the slides, and at the same time, simultaneously, I will go through the practice and the readings. Again, don't forget that you might be able to code, but if you don't read the readings, because now we don't do assessments around readings. Before we did assessments, so you were forced to read them, but now you find yourself skipping those things. Your knowledge may not be complete because you might find yourself in a situation where you don't understand certain concepts, and that is not really good. So I advise that you read the readings. So this is where we started. So let's step through this and see how far we've come. So we looked at primitive data types, conditional statements, loops, writing programs in C#. There should be sharp there. That's C#. We looked at arrays, matrix problems, addition of matrices. We looked at vectors. We also looked at methods and recursion, and now we're going to look at UML. So I'll step through this. Don't forget, why do you use methods? These are things that were under your reading, so kindly read those things. Why use recursion? Of course, that's also under your reading, so please make sure you read those things and see why use methods, why use recursion. So there are reasons here stated for using recursion. Solving complicated combinatorial problems is one of it, because the moment you can derive your recursive dependability, then recursion is always the best way to execute a problem. Exhausting configurations, and you've seen that when we're generating pins or random numbers with recursion. Simulating nested loops, you've also seen that. And designing elegant solutions, recursion usually gives you a few number of lines that are elegant and it makes sense. So please go over this again and see why recursion. And we've looked at practice problems, Fibonacci problem. We've looked at other demonstrations. We've checked why recursion might not be effective sometimes, and I've explained that to you. And direct and indirect recursion, we've looked at that, where a method calls itself, it's direct. When it calls another method, and then that method then calls that first method back, A calls B, B calls C, then C calls A, then we say that method is indirectly recursive. And bottom of recursion is the criteria for stopping recursion. You've seen that also in the practice. Okay, so we've seen factorial problems in recursion. We've seen, so now to the UML. So UML is one of the wrap-up. This is under your reading, so please read about this because I'm not going to test you about it, but I'm just going to give you an idea of what UML is all about. So UML is the unified modeling language. So because there are too many programming languages out there, some people came together and realized, you know what, how do we communicate if you're coding in Java and I'm coding in maybe VB.NET and the syntaxes are different? How do I pass my ideas to you? Can we pass these ideas without even having to write lines of code? And that's the whole idea of UML. So UML is called a unified modeling language, and it has different types of diagrams that convey concepts and ideas that do not involve too much of technicality. So there are sequence diagrams, and there are also other types of diagrams in UML. And in this module, we're not going to go through all of the diagrams in UML because UML has over 22 types of diagrams. There are behavioral diagrams and there are sequence diagrams. You can check these things out, Google it, and read about it. But we're going to touch down on one of the UML kind of diagrams. It's called the class diagram. And the reason why this is interesting to us is because in C# we're going to be having classes. So how can you draw a class diagram if you have a class? All right. Visual Studio allows you to do that with a few clicks, but it's nice to know things from first principle so you can know why you're doing what you're doing. So with UML, I've explained most of the things here, so please be free to read about it. A class is now what we're going to go to the next unit, which is unit 3. What is a class? So when you have a part of your code that's like a template you can use across other parts of your code, you can call that a class. So a formal definition is it's an extensible program code template for creating objects. So if you can think of an object, a student is an object. So I can have a student class. A product in an organization is an object. The product can have a name, price of the product, the name of the supplier. There are many kinds of objects we can think about. Another example of an object is a book. A book is an object because it has an ID. So any kind of entity you think about that has attributes attached to it are referred to as objects. And these objects can be created in C# programming or many other object-oriented programming languages. And that's why we even call these languages object-oriented, because they can handle objects and objects can be defined in these languages. So that's basically the definition. Please be free to read about this. And I'm going to show you now how you can represent an object. So an object has two major parts. The first is the attributes of the object, and the next thing is the methods of the object. How do these things differ? For example, if a student is an object, the attribute is the first name of the student, the last name of the student. Everything that describes that student is an attribute of that student. Think of it in just normal everyday example. So that's what an attribute is of a person. However, the methods of that object will be things that the students can do. So the things a person can do in a person class will be the methods of that person, and the things that describe that person will be the attributes of that person. So we're going to see examples, don't worry about it. So here is how a class diagram looks like. Again, a class diagram is a type of a UML diagram. All right. So you have all the attributes listed in the first box. First, the name of the class, all the attributes listed, and then the methods listed. Again, your access modifiers can be specified in your class diagram. Here's an example of a class. So let's say you have a class that is called book. A book is a class. The title of the book is an attribute of the book because it describes the book. The author of the book or authors is also another attribute of the book. You can think of more attributes of books like ISBN number, publisher of the book, date it was published. Those things are other attributes you can think about. And these are the methods of the book. So if I create a new book, for example, I may want to set the title of that book, or I may want to get the title of an existing book. I may want to set the author or get the author, or even convert the old book to a string, if possible. So these are different methods that I can use on a book. This allows you to start picturing how we're going to be creating our classes, because in Unit 3, a video from now, I'll be explaining to you why we're doing what we're doing, and I'll be referring back to these UML diagrams that I have here. So, again, like I told you, UML diagrams are not language specific, so it allows you to do good software design, to communicate, and that helps across different object-oriented programming languages. Whatever your other colleagues are working on, you can give them UML class diagrams, and they can be able to replicate what you're trying to do or what you're doing. Here's an exercise. Please just enjoy it. Draw a UML diagram that says bank account and put all the attributes and the methods that you think that you want to put in. There are other informations you can show in a UML class diagram. The classes are there. The class must contain the attributes, operations, or you call those things methods, like I explained to you. Also, the access modifiers for visibility. Is it a public class? Is it a private class? All those things also go into your class diagrams. Other things that can be shown with the class diagram are things like relationships. So if you have two classes and one is inheriting another one, that's called inheritance. You can show those things, inheritance. You can show navigability. How do you navigate from one class to another? Multiplicity, and these things are things that are part of your reading, so please read about them. They will not be in any of your labs. However, it's nice to know about it because it constitutes knowledge for you in the space of object orientation. And also you can go to interviews in the near future where people ask you questions about this. As for inheritance, we're going to see examples, and things like interfaces are also features of object orientation. Your class diagram can also contain keywords and sometimes notes and comments. Notes and comments are just like the comments in your programming languages, so they don't differ much. So there's more to UML. UML has, just like I told you, over 22 languages or 22 types of diagrams. And you may want to exploit and see there are circuit diagrams, there are structure diagrams, there are flow diagrams. It's a lot of diagrams in UML. So anytime you're trying to express an idea and you feel like you can show it in the structure, you may want to look at UML to see which appropriate type of diagram would be good for you to demonstrate that idea that you have in your mind. So next, we're going to talk about OOP, object orientation. But just before that, these things I've discussed here, I just want to show you in the readings. And for the readings, I don't want you to forget to read about why recursion, examples. I know we've covered most of the things here, but please just read about the theory of it. For UML also, please endeavor to read about it, the theory of it. So in the reading, I have a couple of things here that I would like you to read about. Please be sure to finish your readings for Unit 2. And for your practice, I also want to show you that we've covered all the practice. Last week, we looked at recursion. So we looked at the implementation of recursion. And we finished the practice for the recursion. So this is the official ending of Unit 2. And in the next unit, Unit 3, I'm going to discuss object orientation and show you classes. We're going to have attributes and methods, private, public. We're going to have inheritance structures and all of those things. So I'll see you on the other side. Boom.